Hello, in this lecture we will find the radius of a circle. In the drawing we have a circle and the center of this circle is at point O, and inside the circle we have a rectangle, and the size of this line segment is 6 units and the size of this line segment is 3 units, and we want to find out the radius of this circle. First of all, we will name this point M. So actually line segment CM equals to 6 units, and we will define this point N, and line segment AN equals to 3 units, and we will also define line segment ON as X. Okay, line segment ON equals to X, and we will define line segment OM as Y, or line segment ON equals to Y. Okay, so actually line segment OC is the radius of this circle because of the fact that it starts from point O, that is the center of this circle, and ends at point C, that is a point on the circle itself. For that reason, it is a radius. Line segment OC is the radius of this circle. Because the definition of a radius is any line segment that starts from the center of the circle and ends at any point on the circle itself is defined as a radius of this circle, and line segment OC satisfying the definition of a radius. Okay, and also line segment OA is also the radius of this circle because of the fact that it starts from point O, that is the center of the circle, and ends at point A, that is a point on the circle itself. For that reason, line segment OA is the radius of this circle. But so if both line segments OC and OA are the radiuses of this circle, they are equal to each other. So we can write down our first equation that states that line segment OC equals to line segment OA because both of them are radiuses of this circle. Okay, so I write down our first equation. Line segment OC equals to line segment OA because both those line segments are the radiuses of this circle. Okay, so our first equation is OC equals to OA because of the fact that both those two line segments are the radiuses of this circle, so that reason they are equal to each other. But actually line segment OC is the radius of this circle, but it is also equals to Y plus 6. Okay, line segment OC equals to Y plus 6. So we can write down here that we can substitute OC by Y plus 6 because OC equals to Y plus 6. And actually OA is the radius of this circle, but it is also equals to x plus 3. Okay, OA equals to x plus 3. So we can substitute OA here in the first equation by x plus 3 because OA equals to x plus 3. Okay. So we have the first equation that states that y plus 6x, y plus 6 equals to x plus 3. You can substitute 6 from equation number 1. Okay, we substituted 6 from equation number 1. So y plus 6 minus 6 equals to y, and x plus 3 minus 6 equals to x minus 3. So we got that y equals to x minus 3. Okay, so actually we have a rectangle OMBN is a rectangle again. OMBN is a rectangle, and the side OM of this rectangle equals to y. So if side OM equals to y, then side BN, the parallel side BN must also be equal to y because of the fact that parallel sides in a rectangle are equal to each other. So if this side OM equals to y, the parallel side BN must be also equal to y. Okay? But we know that y equals to x minus 3, so we can write here that y equals to x minus 3. Okay? And actually line segment OB is the radius of this circle because of the fact that line segment OB starts from point O, that is the center of this circle, and ends at point B, that is a point on the circle itself. For that reason, it is a radius of this circle. It satisfies the definition of a radius of the circle. That is any line segment that starts from the center of the circle and ends at any point on the circle itself is defined as the radius of the circle, and line segment OB satisfies the definition of a radius of a circle. For that reason, line segment OB is the radius of this circle. But OA is also the radius of this circle for the same reason. And OA equals to x plus 3. So OB will also be equal to x plus 3 because OB is also the radius of this circle, and those two radiuses are equal to each other. So if OA, that is the radius of this circle, equals to x plus 3, then OB, that is also the radius, will be equal to x plus 3. Okay, so OB equals to x plus 3, and OB, that is the radius of the circle, equals to x plus 3. And actually the angles in a rectangle are all equal to 90 degrees, so angle O and B in the rectangle equals to 90 degrees because all the angles in a rectangle equals to 90 degrees. Okay, so angle O and B equals to 90 degrees. We actually, in the right triangle O and B, triangle O and B, we know that the hypotenuse equals to x plus 3, ON equals to x, and this side of the rectangle, side NB, equals to y that equals to x minus 3. So we actually can use the Pythagorean theorem in order to find out the value of x. Actually, the Pythagorean theorem states that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So actually, we can implement the Pythagorean theorem in our right triangle. So actually we can write down that the square of the hypotenuse is OB square equals to the sum of the squares of the perpendiculars equals to ON square plus BN square. Okay, so our second equation will be the implementation of the Pythagorean theorem in our green right triangle OBN. The square of the hypotenuse is OB square equals to the sum of the squares of the perpendiculars equals to ON square plus BN square. Okay, again, according to the Pythagorean theorem, in the right triangle O and B, the square of the hypotenuse is OB square equals to the sum of the squares of the perpendiculars equals to ON square plus BN square. But we know that OB equals to x plus 3. Okay, OB equals to x plus 3. So we can substitute OB in the second equation by x plus 3 because OB equals to x plus 3. And ON equals to x. So we can substitute ON by x in the second equation. And BN equals to x minus 3 equals to y that equals to y minus 3. So we can substitute Bn in the second equation by x minus 3 because Bn equals to x minus 3. Okay. So we'll substitute OB by x plus 3, we'll substitute ON by x, and we'll substitute Bn by x minus 3. Okay. Okay, again, we substituted OB by x plus 3. We substituted ON by x, and we substituted Bn by x minus 3. We got that x plus 3 square equals to x square plus x minus 3 square. Now we will open the brackets in the second equation. Okay, we open the brackets in this equation. Actually, x plus 3 square equals to x square plus 9 plus 6x according to the equation that a plus b square equals to a square plus b square plus 2 times ab. And here x minus 3 square equals to x square plus 9 minus 6x according to the equation that a minus b square equals to a square plus b square minus 2 times ab. Okay. Then actually we can cancel here. We have x square here and x square in the other side of the equation, so we can cancel x square. And we have 9 in this side of the equation and 9 in this side of the equation, so we can cancel 9. So what is left? Here, the only expression that left is 6x, and in the other side of the equation, we left it with x squared minus 6x, okay? So I will write it now. Okay, now we will subtract 6x from equation number 2. So we subtracted 6x from this equation number 2. 6x minus 6x equals to 0, and x squared minus 6x equals to x squared minus 12x, because minus 6x minus 6x equals to 12x, so in total we got x squared minus 12x. Okay, and here we will take a common factor x out of equation number 2. Again, we will take a common factor x out of equation number 2. We will get that so we took a common factor x out of equation number 2. We got that 0 equals to x times x minus 12. Actually, the solution to this equation is, we have two solutions. The first solution, x equals to 0, is impossible because x is the side of the rectangle, and it can never be 0 because it must be a positive number. When you talk about size of any shape, any geometric shape, it must be a positive number. So x equals to 0 is incorrect answer solution, and the other solution, x minus 12 equals to 0. So we have x minus 12 equals to 0, so actually x equals to 12 units. Okay, we got that x equals to 12 units, but we know that the radius of this circle is x plus 3. Okay, the radius of this circle is x plus 3, so the radius of the circle will be x plus 3, that is to say x equals to 12 units, it's 12 plus 3 is 15, or the radius of the circle is equals to 15 units. Okay, the radius of the circle is x plus 3 and x equals to 12, so the radius of this circle is 15 units. Okay, so now I'll summarize the lecture. Actually, we wanted to find out the radius of this circle. The center of this circle is at point O, and inside the circle we have a rectangle, and we know that line segment MC is 6 units and line segment AN is 3 units. So we defined line segment OM as Y and line segment ON as X, and actually OC is the radius of this circle because of the fact that it starts from the center of the circle and ends at point C, that is a point on the circle itself. For that reason OC is the radius of this circle, and line segment OA is also the radius of this circle because of the fact that it starts from the center of the circle and ends at point A, that is a point on the circle itself. For that reason OA is the radius of this circle. So OC and OA are both the radius of this circle. So because of this fact that both of them are radiuses of this circle, they are equal to each other. Okay, so we have our first equation that states that OC equals to OA equals to the radiuses. So they equal to each other because both of them are the radiuses of this circle. But we know that OC equals to Y plus 6, so we can substitute OC by Y plus 6. And we know that OA equals to X plus 3, so we can substitute OA by X plus 3. So then we substituted 6 from this first equation. We got that Y equals to X minus 3. And we actually know that OB is the radius of this circle because it starts from the center of the circle and ends at point B, that is a point on the circle itself. For that reason OB is the radius of this circle. But if OA is the radius of the circle, it equals to X plus 3, so OB, that is also the radius of this circle, must be equal to X plus 3 because both of them are radiuses of this circle. For that reason OB also equals to X plus 3. And we have a rectangle, so in a rectangle the parallel sides are equal to each other, so if this side is Y, this side is also Y. But we know also that Y equals to X minus 3, so we can substitute, we can write here that Y equals to X minus 3. So actually this angle is 90 degrees because all the angles in a rectangle equals to 90 degrees, so we can find out the value of x in the right green triangle according to the Pythagorean theorem. The Pythagorean theorem states that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, OB square equals to ON square plus BM square. So this is our second equation. The square of the hypotenuse equals to the sum of the square of the perpendiculars. But we know that Bn equals to x minus 3 and O equals to x and OB equals to x minus 3. So we can substitute OB by x plus 3 and O by x and Bn by x minus 3. So we did it. We got that x plus 3 square equals to x square plus x minus 3 square. We solved this simple second equation. We got that x equals to 12 units. X equals to 12 units. But the radius of the circle equals to x plus 3. So the radius of the circle will be x plus 3, that is to say 12 plus 3 or 15. The radius of the circle equals to 15 units. Okay, that is the answer to the question, that the radius of this circle equals to 15 units. Okay, thank you very much.